Hello, network engineers. Welcome to session 5 of this segment routing series. In this session, we are going to learn about SRMPLS and LDP interworking. So as mentioned previously, the data plane of LDP and SRMPLS is same, but the control plane differs. So what is the operations in data plane? Push, pop, and swap. Okay, LDP utilizes LDP binding, where SRMPLS exchanges index value and each router calculates label out of it. So the label calculated from index value is called prefix seed, and it by default it follows shortest path. LDP also follows the shortest path. So in terms of data plane, there would be no difference. So in first phase, we will see how loopback of P5, let's say which is 5.5.5.5 and with index value 5, how this label will be placed in LFIP table for on P2 and P1 routers. So let's directly jump on P3 and let's create the end 3. So on P3, our outgoing label would be 16,005. Interface is inside the LDP domain. So instead of calculating index incoming label from on the basis of the index value, P3 router will create local label from dynamic range. So network engineer, what is the dynamic range? So dynamic range is a label which starts from 24,000 and ends with 2 raised to 20 minus 1. I believe label length is 20 bits, so it would be 2 raised to 20 minus 1. Okay, so let's say LDP has created 24,001 for local label. P2 will receive the LDP binding for this entry, and P2 will calculate outgoing label as 24,001 and incoming label as any random label from dynamic range. So let's say 24,002. Okay, so same way here. So here out label would be 24,002 and local label would be anything which is random. Let's make it 24,003. So in order to make this entry, we don't need any configuration. So P3 by default create this entry where outgoing label would be calculated from index value and local label would be calculated from the dynamic range. So if I'll do a trace route to 5.5.5, the MPLS path should be through. So let's go to lab router and see these transactions. So we are on P3. So if we see forwarding table, forwarding, so we have outgoing label as 16,005 and local label as 24,006. And we see we are receiving this entry from the LDP bindings to P2. Okay. So if we do a trace route from P1 to P5, our MPLS part would be through. And on each hop, we will see the respective label. And on P4, we will see the implicit null. So let me go to P1 and issue trace route command. Okay, so you can see the packets are reaching till last hop. Okay, now let's see the another transaction. Now our P1, let me remove all this thing. Now let's see interchange of label from LDP to SRMPLS. So this would be our scenario 2. So in this scenario, P1 would be our root router. So now let's again go to P3 as P3 is our border router. Now in order to so now in order to create label in SRMPLS domain, we need to push the index value for 1.1.1.1. So, so by default, that will not happen. So in order to advertise the index value, we need to create a segment routing mapping server, and we need to associate index value with the loopback of P1. So the configuration will look like this. So if we need to go inside segment routing, then mapping server prefix seed map, and inside address family we need to define prefix and the index value. After that, there's an option of range also, where we can define multiple label for a particular subnet. Okay, so once we place this configuration on P3, it will make segment routing SRM segment routing mapping server as active, and then it will send the index value for 1.1.1 all over the SRMPLS domain, and each router will calculate the label accordingly. So let's go and see that transaction as well. So on P3, let me let me do a let me do a quick trace route from P5 to P1, and I'll show that by default transaction will not happen in that direction. So we'll see a broken LSP. So you'll not see on each hop label would be pushed pop or swap, because from P5 perspective, P5 hasn't received the index value of 1.1.1, so P5 will not calculate the segment routing label, which would be 16,001 basically. So let's go to P5 first. Let's go to P5 and let's see if there is an entry for 1.1.1. Well, there is an entry. Might be I have configured segment routing mapping server already. So run segment routing mapping server. Oh, config the segment routing. Config the segment routing. No, no mapping server. Commit. Those registered as location all. Now we don't see any local label being created for 1.1.1.1. If there is no local label, there would not be outgoing label as well. Still, let me show you the MPLS forwarding table. MPLS forwarding. So there is no entry with 16,001. Okay, so if I'll do a trace out to 1.1.1, which shows 5.5.5.5, we won't see the label, right? So that means the MPLS path is broken here. And now let's configure the segment routing mapping server for 1.1.1.1. So let's go to P3, config the segment routing mapping server prefix seed map, IP address family IPv4, and then we can go for 1.1.1/32, and then I'll give the label 1. There would be an option of range. Since we are focusing on single prefix, we don't need range. And then we need to go inside ISIS hierarchy, address family IPv4. Inside this, we need to advertise the segment routing. Segment routing MPLS. uh, segment routing prefixed map, and then receive is by default on, advertise local, route show commit. Yeah, and now if I do a trace route to 1.1.1, now trace route there should be no label broken, and the path should be through via MPLS path only, label path only. So let's see 1.1.1.1 source 5.5.5.5, and here we go. So the things are simple here. So the border router will exchange segment routing prefixes and create bindings automatically, and propagate that binding through LDP protocol. No need to place any separate configuration. But vice versa is not true, where the LDP prefixes need to have index value so that the routers inside the SR domain can calculate the label for the prefixes which belongs to LDP domain. So segment routing cannot calculate label without without index value. Uh, Now root router become P3 because P3 will advertise the index value for P1. So instead of P1 as a root router, P3 will become the root router.